Welcome back. Today we're going to be looking at section 3.4, which is composition of functions, which also includes operations on functions and the four main ones. So we're going to dive right in because we've got a couple different things to cover today. The first of which is going to be the four primary operations, which we've already seen happen on integers and on real numbers, but happen on functions. What happens if you add two functions together? What happens if you subtract two functions? What happens if you multiply two functions and divide? First things first, I need to look at this small little typo on the completer notes that we'll fix. This plus sign right here is supposed to definitely be, if you look over here, there's a minus sign. That was a copy and paste error that we will fix online. So we've got actually addition, subtraction, multiplication, which is an invisible little sign, and division with a domain restriction like we always have when we have a division, right? We've looked at if you have an X on the bottom, you have to include that domain restriction. So really what we're going to do is we're just going to show you a couple of these, and then we'll move right on to the meat of the day's lesson, which is the composition of two functions, or three. And so the first thing we're going to do is multiply two functions because it asks us to, f times g. And so right here we'll just go f of x times g of x, which is another way to write it that makes it seem a little more friendly. I might write this over here, f of g of x. It's the same thing as f times g of x, and that's the same thing as a normal binomial multiplication that we've done many times already in this class. So we're going to use our FOIL, our first, outer, inner, last. Notice how we're getting faster at trying to do that. And if you multiply the first terms, you get x third. If you multiply the outer terms, you get, I'm going to do the inner first because we have the higher exponent, x squared. If you multiply the outer terms, you get negative x. And if you multiply the last terms, you get plus 1. So you get no like terms because you don't have the same variable and the same exponent happening. So we can't combine any of those. And we're just left with our answer to our multiplication problem. Now let's do the exact same thing, but with subtraction, because that's what it asks us for. So f minus g of x is the same thing as f of x minus g of x. Just a different way to write it that looks a little prettier for us to plug and chug. And then we're going to subtract the two things. So I'm going to take f of x, which is x minus 1, and I'm going to subtract g of x, which is x squared minus 1. And because we have a negative outside of the parenthesis, we're going to distribute that negative sign and yield x minus 1 minus x squared plus 1. So that's negative x squared plus x. Ooh, and the minus 1 and the plus 1 kind of do a nice little canceling. So I don't really understand why the book asked are they the same function, but we can clearly say no, they're not the same function. These two are very different functions. And that's that. So what we've done is we've multiplied, we've subtracted. You could use the same processes to divide and to add, and you should go look at those exercises in the text and try to practice a few on your own before starting the homework. Let's move on to the meat of this lesson, which is the composition of functions. So this is like a function and another function, and if you were to plug one inside of the other, so like Inception, if you've seen the movie Inception, where they go into dreams within dreams within dreams, and even to the third level of a dream, that's kind of what we're doing here. We're talking about a function inside of a function, inside of another function even maybe, all wrapped up with an input inside of that. So you've got like an input inside of an H, inside of a G, inside of an F, and you just keep kaleidoscoping down as many times as you want to. That's kind of what composition looks like. The only unique thing is there's a unique domain condition because we've got a little bit different of an operation happening. So let's hop right into that. First things first, we'll solve, and we'll say, okay, well, what happens if you take this at its bare bones? Can you do anything to 1? No. But can you plug 1 into G? Absolutely. And maybe we should to get started. So f of G of 1 is going to be the same thing as f of, and can we solve the problem on its own, G of 1? Well, G of 1 is to take 1 and to plug it into G. So if we input 1, it outputs 3. So f of g of 1 is the same thing as f of 3, and then we can do that problem separately. F of 3 is 3. And we've plugged it into an equation by taking a two-step, or a one-step problem and turning it into 2 steps. We might do the same thing for f of 4. There's f of 4 in green. So f of 4 was 1, and so f of g, g of f of 4 is the same thing as g of 1 is the same thing as, oh look, we've already done that once today, 3. So we've got ourselves how to solve kaleidoscoping or composed or compositional functions When you're given a table, you can do the same thing with a graph if you have one by just plotting points on the graph and realizing a graph is just a table with a line drawn through it, and you can get your x and your y points. Oh, and that's what we'll probably do right here. We'll just do it real quick. F of 2. Can you start on the inside, work your way out? Can you do anything to 2? No. Can you do something to f of 2? Sure, you could solve it. So go to the f graph, which is right there for your f of 2. Go to 2, work your way up until you hit the blue line, and it looks like you've got the point 2, 5, which means that f of 2 is 5. And thus, g of f of 2 is the same thing as g of 5, which is going to be, hop over to your g graph, go to 5, go up, and you'll end up with 3. So g of f of 2, same thing as g of 5, which yields 3 as an output. I got a lot of 3s today. All right, but sometimes they don't give you a graph or a table, and it's not as nice and neat. And they say, hey, I need you to do it all on your own with the function. And that's okay. We're going to use the exact same thing. It's just going to take one extra step of plugging and chugging or inputting and outputting that number. And so what we're going to do, can we do anything with the 2? No. Take it one step out. Can you do something with that blue f of 2? Sure, you can plug and chug it in and find out what is f of 2. Well, f of 2 is just going to be 2 squared minus 2. 4 minus 2 is 2. Now we're going to take that and we're going to plug it into h. So we've got h of 2. And where did we get that 2? We didn't get it from the original problem. I know it's a little confusing. We got it from right there. That's where we got our 2 from, because we switched out what is the solution of f of 2. And it was 2. So now h of 2 yields, we need to plug it in and see, 3 times 2 plus 2, which is going to be 8. 6 plus 2 is 8. And we've got ourselves composite functions solved. All right, now here's where it gets real tricky, is the domain. So the domain of all the functions we've done before are pretty standard. We said we look for the 2 things, right? 2 bad numbers. You look for a bad number on the denominator, you look for a domain restriction in your denominator, or you look for a domain restriction in the inside of a square root, right? We talked about that domain. You look for restrictions, and the place you look for restrictions are square roots and numbers over 0. Negative number here, that's bad, and a 0 on the bottom, that's bad. But this is going to be a little different because we've got 2 functions. We're going to say, well, we've got 2 functions and technically 3 if we do our composite function. And so we kind of want to know which of those do we need to check. And so what we're going to check is we are going to check the inside function. We're going to check the composite function. And we're going to check the... Nope, that's it. We're going to check the inside and the composite. We're not going to check the outside function by itself. We don't need the outside function by itself. We need the inside and we need the composite. So we are going to check the inside function first. We've got, I'll do the problem inside of this box. F of g of x is what it asks us for the domain. And so we're going to say check the inside function, check g of x. So let's do the g of x domain. Domain of g of x, right? The domain of g of x, we said we can't have any bad numbers in the middle, right? So we've got g of x equals x plus 4. We say x plus 4 better be bigger than or equal to 0, which means that x better be bigger than or equal to negative 4, which means that our domain is going to be from negative 4 to infinity. And anything below that we have to cross out of our domain. Okay, so we found the domain of the inside function. Now let's find the domain of the composite function itself. In order to do this, we're probably going to need to find that composite function. And so we're going to find f of g of x by plugging in g of x into f of x, which is 1 over root x plus 4 minus 2. What we did is we took g of x and we plugged it into f of x because it's like a function inside of a function. And now we need to find the domain of that. And well, we've got 2 things happening. We've got 2 bad things. We've got a denominator with an x in it, and we've got a square root. And we need to check on both of them. So the first thing I'm going to do is check on that square root and realize really fast that that square root has the same condition as the one before, that x plus 4 better be bigger than or equal to 0, which means that x better be bigger than or equal to negative 4, which means that we've got negative 4 to infinity as one of our conditions on this big function. Second condition, if you remember, you have a fraction with an x on the bottom, it better not ever be equal to 0. And so we are going to say the second condition is that this whole bottom cannot be equal to 0. Right? The whole denominator cannot be equal to 0. If it equals 0, we got a bad number, we're in trouble. So we're going to draw our line down and solve like we would solve any inequality, linear, radical. We're just moving stuff over. So move over the 2. How do we get rid of a square root? We square it. So x plus 4 better not equal 4, which means x better not equal 0. That's it. I'm going to check that just to see because it's kind of a weird condition. What happens if we plug 0 in up here for x? Watch, that highlighted area, I'm going to plug 0 in. 0 plus 4 is 4. The square root of 4 is 2. And if we plug in 2, 2 minus 2 is 0 on the bottom. That would be bad. So that checks out. X better not be 0. And now I'm going to throw all of that on a number line, all 3 of these conditions. We got one condition from g of x, one condition from f of g of x, and another condition from f of g of x. I'm going to use a number line because it's going to make it easier to draw an interval. I'm going to say we cannot be 0. We go over to -4 as our other special point. And then we go over a couple more, and then that should be good. So we say, well, it has to be bigger than -4, right? And including it. I'll do this in blue. It has to be bigger than -4 and including it. Can't include 0, leave an open circle there. But everything else is fair game. And so our domain's going to look like that on a number line. And the easiest way to build an interval is to look at your number line and just build it out right below your number line. So there's my number line. I'm going to go, starting with the closed bracket at -4 because it's a closed circle. -4, comma, all the way to the next special point, which is 0. Open it up and do not include 0 because we got to cut it out. And then we're going to go all the way to infinity if my screen isn't freezing. All right. There we go. And so that one has a little more work because we had to do 2 things. We had to find the inside domain and then we had to find the composite domain, right? And that takes a little bit of time, a little bit of work, but it's not too bad. The other ones are just like we've done before. If you're working through an operation, which we did at the top of the day, plus, minus, multiplication, division, the domain calculation is exactly what we've done in the past, where you have to check for radicals and check for fractions. Awesome. Thank you so much. As we approach the end of Chapter 3, we're getting kind of close to our tests, so it might be worth reviewing some of the old homeworks, exercises, some of the old videos, reading through the textbook, as we get a little bit closer to this Chapter 3 test coming up. I hope you have a good day, and good luck in your studies, and I'll see you next time.